Greetings to all the learners. I am Faculty of Science in SRN International School and I welcome you all to the SRN Knowledge Center. Dear learners, today we are going to study a chapter in class 10th, that is Chemical Reactions, a very important chapter with a weightage of about 5 marks in the board examination. This chapter is so important that it is the background of chemistry. So let us start with Chemical Reactions, chapter number 1 of chemistry. What do we study in chemical reactions? So basically there are two types of changes in a chemical reaction. It can be a physical change or a permanent change. Most of the substances around us undergo changes. Some of these changes can be temporary with no new substance being formed. They are called as physical changes. In certain other changes, new substances are formed and the parent substance loses its identity. In such change, we cannot get back the original substance from the new substance by simple means. So they are called as permanent changes. As you can see in the slide, a burning of the paper is considered to be a permanent change because a new substance is being formed over here. Let us now think about what are the topics that we are going to learn in this chapter. So we are going to recognize the chemical changes, write the equations to represent a chemical reaction, classify chemical reactions, and we are going to list some examples for different type of chemical reactions. Now let us start with a chemical reaction. A chemical reaction is basically that reaction in which a new product is being formed. There can also be emission of energy or light or production of a new colored compound. So a chemical reaction is that in which a substance or substance react chemically to form a new substance or substances. So the substances that take part in a chemical reaction are called as reactants. Dear learners, the reactants always come on the left hand side and after the arrow we write down the products. So a chemical reaction has been shown to you over here where we can see iron and sulfur on the left hand side and iron sulfide being formed as a product. When sugar is heated, it gets charred. I hope you all know what's charred. A smelling of burning sugar is there and the sugar turns into black colored compound. So that is called as charring. Here we can see the formula of sugar, that is C12H22O11, and is being converted into 12 moles of carbon along with 11 moles of water. So this is an example of a chemical reaction. How to write a chemical reaction? This is the most important aspect. So as already being discussed with you, the reactants come on the left hand side and the products on the right hand side. In the above slide, you can see aluminum oxide on the left hand side along with sulfuric acid, that is the reactant, and the product that is being formed is aluminum sulfate along with water. So what are the steps while writing a chemical reaction? So the steps are: symbols and formulas of reactants are written first on the left hand side. If there is more than one reactant, then the plus sign is placed between the different reactants. Aluminum oxide and dilute sulfuric acid, for instance, are written as under. So you can see over here that I am writing the formula of aluminum oxide along with sulfuric acid. An arrow is marked after the reactants to indicate that they react to form products. So whatever is now coming on the right hand side will be considered as the product. So here the products that are formed are aluminum sulfate along with 3 moles of water. The chemical equations are based on the law of conservation of mass. Now what is law of conservation of mass? It is that the reactant's mass always remains equal to the mass of the product. You can see over here, iron reacts with sulfur to form iron sulfide. So according to this law, the mass can neither be created nor be destroyed in a chemical reaction. This will be possible only if the total number of each type of atom is same on the reactant side as well as on the product side of the equation. Equations in which the number of atoms of different elements in the reactants are same as the number of atoms on the product side are known as a balanced equation. A very simple example of a balanced equation is if you go to buy sugar to a grocer's shop, there he will be adding some sugar or removing some sugar unless he gets the desired quantity of sugar. So that is in a balanced chemical equation. You can add on something or you can remove something unless you finally end up with the balanced equation. Now these are balancings of equations. Aluminum oxide reacts with sulfuric acid to form aluminum sulfate along with water. Here aluminium oxide reacts with 3 moles of sulfuric acid ending up in aluminium sulfate plus water. So these are the reactions that which we can study how the reaction can be balanced. At the end of the reaction, we need to check the mole on the reactant side is equal to the mole on the product side. Now let us study the different type of chemical reactions. The reactions can be a combination reaction, a decomposition reaction, displacement reaction, or a double displacement reaction. So dear learners, let us study these reactions one by one. Starting with a combination reaction. As the name itself suggests you, combination means adding of the two reactants to form a product. Here in the slide you can see hydrogen and oxygen is combining to form water. Copper and oxygen is combining to form copper oxide, and iron and oxygen is forming rust, that is iron oxide. So a reaction where a new matter is added to the original substance and the substance gains in mass, such a reaction is called as a combination or synthesis reaction. Combination reactions are those in which one element reacts with another to form a compound. Such reactions are also the example of synthesis reactions. Let us now see the reaction of magnesium with oxygen. It forms magnesium oxide or magnesium hydroxide. These are alkali substances, that is, they are basic in nature. Let us see the activity. We take a magnesium ribbon and heat it over a flame. It burns, giving out a bright white light. You have seen the firecrackers. The firecrackers, for example, the sparkles, they give a dazzling white flame. So it is composed of magnesium. The magnesium ribbon burns, becomes white powder, and when we add some water to the powder and put a drop of red litmus, the red litmus turns blue. What does it indicate? It indicates that the magnesium hydroxide or oxide is a basic substance, because we know that the red litmus turns blue when it is added to a basic substance. Now, just the reverse of a combination reaction is called as a decomposition reaction. Decomposition means breaking down. You can see in the slide calcium carbonate is a reactant and breaks down into calcium oxide and carbon dioxide. So the decomposition reactions are those in which a compounds break down into simpler compounds. For example, on heating calcium carbonate decomposes to give calcium oxide and carbon dioxide. Decomposition reactions are those reactions in which two new products can be formed. So let us now see an activity. We take a piece of marble, hold it with a pair of tongs, and we heat it over a flame for some time. Allow it to cool, and then we add some water to it and add a drop of red litmus to the solution. The color of the litmus changes to blue. The moment we get a blue color, we know that this is a alkaline substance, or in other words, it is a basic substance. Another activity in this, we take 0.5 gram of zinc carbonate in a test tube and we fitted the test tube with a cork and the delivery tube. We heat it over the flame. A colorless gas is given out. Which is this gas? This gas is carbon dioxide. And how to test carbon dioxide? It turns lime water milky. A very important question in the board examination. So thank you very much, and if you really like the video, please share and subscribe this video. I'll be coming with more interesting subject videos and knowledge videos in the coming session. Thank you very much.